Good morning all, the jury members, host of the event, mentor and my team member, myself Dr. Pooja Kumari Maset, Sumit, Aswini and Mr. Suraj Naik. Our problem statement is to develop a smart device to improve patient alignment and positioning for the arthroscopic surgery. The second slide is for need and the market. The medical problem is to stabilize the patient to prevent inadvertent movement and protect the patient from injury during arthroscopic surgery. Major limitations are the existing limb positioners like Spider 2, Ethebrix, etc. need more manpower. It's time consuming and has a more complex setup. Also, they are expensive, have a improper padding as well as a need separate device for positioning arm and leg. Market size, a global arthroscopy instrument market is projected to reach up to USD 5.61 million by 2022. Key functional requirements are the adjust positions of the limb up to 0 to 90 degree in shoulder flexion, abduction and lower limb up to 0 to 40 degree in uh, hip abductions and 0 to 60 degree in hip flexion. The product should be easy to operate, increase safety by adding soft materials and improving ergonomics, and also sensors to measure our patient vitals. Those are respiratory rate, heart rate, SpO2 and blood. The third slide is proposed solutions. So as the durability and visibility ensure, here we prepare a viable business model to prove our competitive advantage over existing limb positioner device. To tackle this problem, we propose a robotic arm with gesture control features which can be added to a guide railings present at the side of side as shown in the image of a concept sketch. In the CAD model figures here, a bed attached with a robotic arm is shown. There is a digital display feedback to show ranges of the limb in flexion and extension position, as well as aquapad are fitted on the bed as well as the gripper so as to prevent a compression of a limb. The component of an arm include a slider for a moving assembly along the bed, the turntable for rotating the assembly, connecting links actuated by a motors, and a gripping at the end, and a digital display for a feedback. In simulations, we tested the force of the robotic arm and it can be concluded that it can sustain a 50 kg of a weight. For next slide is proof of a concept. A proof of a concept, the first photo represents a physical model of a robotic arm. In photo on the right side shows a gripper model with a foam and a biosensor patch attached for a proper cushioning and measuring vitals. A below photo shows a gesture control circuit. The video, okay, this video shows the movement of a robotic arm using gesture control in upward, downward and a sideward direction. Moving next slide. Summary. So the customer segments are private hospital, medical NGOs, foundations, doctors. The value propositions are accurate alignment and positioning, prevent neuroparaxia, reduce manpower, sense vital, easy to operate. Piercing and scales, initial sales cost is up to 70,000 and approx 2 times lesser than the existing products, one-time investment. Partners are Dr. James Divade, BRAC, Medical Instrument Manufacturing Company. So in conclusion, I would like to say a robotic arm with the gesture control features was developed for accurate patient alignment and positioning for surgery, and the device senses the vitals of the patient. Thank you for listening to me.